So, sorry for the late drop of the lesson. There's lots of things that contributed to it. Tons of meetings and technical difficulties, and the fact that this presentation itself took me 5+ hours to create because of all the graphics. So, I hope you appreciate it. Um, it's on graphing the sine function. Basically, we were just going to be doing an exploration and just a summary of what we went over. So it's all kind of based on this Ferris wheel at an amusement park called the Screamer. So just you could there's a picture of Screamer right there on the billboard, and so you can just read along with me here. So it says, "Hurry, let's get there before the line gets too long," shouts Antonio to his best friend Renee as they race to get on the Screamer, the newest attraction at the local amusement park. "It's only been open for one day, and already everyone is saying it's the scariest ride at the park," exclaims Antonio. "I hear that they really had to rush to get it done in time for summer." Antonio whistles as he screeches to a halt in front of a huge sign that says, "Welcome to the Screamer, the scariest ride on Earth." The picture on the sign shows an enormous wheel that represents the Screamer within a 100-foot radius. Half of the wheel is below ground level in a very dark, murky pit with water at the bottom. As the Screamer rotates at dizzying speeds, riders fly up into the air before plunging downward through blasts of freezing air and sticky spider webs into a pit where they splash through the dark, eerie water on their way back above ground. Renee and Antonio wait impatiently to get on the ride, watching passengers load and unload. New passengers get on and strap themselves in as others emerge from the pit looking queasy. The wheel rotates 15 degrees to load and unload the next set of riders. As Renee straps himself in, he remembers Antonio's ominous words, "I hear they really had to rush to get it done in time for summer." Sure enough, just as the ride plunges Renee and Antonio into the murky water, they hear the piercing scream of metal twisting. Sparks fly and the pit fills with smoke as the ride grinds to a halt. To escape, all of the passengers must climb vertically to ground level from wherever they got stuck, either up from the pit or down from dizzying heights. Your task: write a function that describes how far above or below the platform a rider is when the Screamer breaks down. Okay, so we're going to do like an exploration. We're going to start off with just a model here. So this model here is of the Screamer. The circle is the wheel of the Screamer, the blue circle there, and the lines coming out from the center are 15 degrees apart. And remember, it rotates every 15 degrees to load new passengers, and that means that all the seats in the Screamer are 15 degrees apart. Okay, so first we're just kind of like go over like what really it's asking us for, right? Because it's talking about the Screamer is at a halt and people have to climb up or down to the ground. So remember this: the x-axis here is the ground, and the top half of the circle is like right above ground, and the bottom half of the circle is below ground. So for example, here, this dot is one of the seats, and its height is 0, so these guys do not need to climb. So their degree is 0, and then their height and the model is 0. And the model of this is has a radius of 1, and the actual wheel is 100 foot radius. So you just multiply by your model height to get the actual height. But 0 times 100 is still 0, so the actual height is 0. Now the next seat is another 15 degrees, so it's up here. So, and its height is 0.259 in the model, and so its actual height is, when you multiply by 100, so it's 25.88. Now, we'll talk about later how they're getting these numbers, but I just want you to get the idea, like that the next seat is 15 degrees, and they have to climb down about 25 feet. So that's the idea. So then the next seat's another 15 degrees. So then now we're at the 30 degrees. And then they have to climb down 0.5 in the model. So that's 50 feet in actuality. And then the next seat is another 15 degrees, which is 45 degrees. And in the model, the height is 0.7, and then the actual height is 70. And then just for all the ones that we've done so far, right, are above ground. So let's skip ahead to just a random one down below at 285 degrees. So 285, it has a height of negative 0.966, which because it's below ground, but the distance that they have to climb, right, is a positive distance. So we'll just say that they have to climb 0.96 in the model. So in reality, it'll be times 100, so 96.59. Okay, now let's get into, now maybe you get the idea of like where all the seats are and like where from like which direction they have to climb. That's what I hope you understand so far. Now what we'll get into is like where are these numbers coming from? So let's do the easy heights first. So the easy ones, of course, are the 0 degrees and the 180 degrees, because both of those are level with the ground, so they don't have to climb at all. So we already have the 0, 0 on our table, but then now we can add 180 degrees. They also is 0, and they do not have to climb. Okay, the other really easy heights are the highest point on the wheel and the lowest point on the wheel. So the highest point is 90 degrees and the lowest point is 270, right? Remember, around a whole circle is 360 degrees. So those both in our model have a height of 1. And so we'll put those. So 90 has a height of 1 in our model, multiply by 100. Our actual height, they have to climb 100 degrees. And then for 270, 1, and then they have to climb up 100 degrees. Okay, so then now let's get into some of the triangles that some of the heights that we've already done. Now to do that, found the heights, 40 and slip there, you have to draw triangles. So here's a triangle. Now remember, the radius is 1, it's labeled there, and then the height that they have to climb down, 0.26, is labeled there. And then remember, that's the first one of the first seats, so it's 15 degrees. And then the triangle, you can see if you draw straight down, it's a right triangle, so then the other degrees is 75. So we already have that in our table, the 15 degree one. That's our second row in our table. Then the third row in the table, we also have that triangle looks like this. So we already have the numbers. So when we get to a triangle that we don't have numbers, I'll explain how you get the numbers. So that's the next seat, that's 30 degrees, and that has a height of 0.5, and they have to climb down 50 feet. The next one's 45 degrees, so like you remember, it's in increments of 15. They have to climb down about 70 feet. And then this is our first triangle that we don't have in our table yet. And as you can see, so it's at 60 degrees and straight down creates a right angle. So this triangle is a 30, 60, 90 degree triangle. And then that's why we went over special right triangle. So let's remember our 30, 60, 90 ratios. So well, first of all, I spoke too soon. So basically, how do we find sides of right triangles, right? Like we have lots of tools to us for finding right triangles, right? We have Pythagorean theorem, we have like special right triangles, we have trig, but we actually only have one side. We have this, the radius is 1, right? And then so we can't use Pythagorean theorem, but since it's a 30, 60, 90 triangle, we can use the ratios that we learned. So here are the ratios. So remember the hypotenuse is double the short side. So for this one instance, our hypotenuse is 1, right? And so if the hypotenuse is double the short side, then the short side is 1/2, right? Or 0.5. And remember the ratio for the long leg is the short leg times √3, and the long leg is our height. So that's the angle here. So the long leg is 0.5 times √3, which is 0.866. So there we have it. Our height that you have to climb down at the 60-degree seat on the wheel is 0.86 in our model. So we'll put that on our table, and then the actual height is around 86 feet. Okay, so the next triangle is another 15 degrees, so that's 75 degrees. And remember, we know that the radius is 1. Now for this triangle, right, it's 75 degrees with a right angle, so that makes the other degrees 15 degrees. But this isn't one of our special right triangles, right? And we can't use Pythagorean theorem because we only have one side. It's not one of our special right triangles. So then our next option is trig. Now, if you remember, so basically SOHCAHTOA, we used that to find the missing sides. So basically we need to figure out which sine, cosine, or tangent do we use with this 75-degree angle. So the one is the hypotenuse, right, which we have, right? And then the height is either the opposite leg or the adjacent leg to 75. It's the opposite. So the ratio that you use with opposite and hypotenuse is sine. So sine of 75, right, is opposite of hypotenuse, and this is how we'll solve for that height. So we know that the hypotenuse is 1, so we plug that in. And then that's opposite over 1 is just the opposite. So really sine of 75 is that height. So sine of 75, you plug into your calculator and you get 0.965, and then that's the height. So 0.9 rounded 0.97 there. So we'll put that in onto our table. So 0.9659. Actual height is 96.59. Okay, so the next angles is 90 degrees, which we already have. So then the one after that is another 15, so that's 105. So you're probably like, well, how do I find the height there? Again, you draw a triangle and you draw straight down. So you draw from the seat straight down to the ground, right? Because that's the length that they'll have to climb down. And you'll notice it's the 75-15 again. And so it's the same height that they have to climb down as the last triangle. And what you're going to see is you're going to see some more patterns and more of the same triangles. And I'm going to talk about that. And that's how we're going to fill in the rest of our table. So I'm not going to do the computations because you get the idea. You're either going to use sine or you're going to use special right triangles. You can use sine for all of them if you like. So now we have for 105, it's 0.965, so 96.59. Then the next 15 will be 120 degrees, and then you draw a triangle there. That's the 30, 60, 90 triangle that we already saw, right, with a height of 0.87. So the height is 0.866, and so they climb down about 86 feet. Then another 15 is 135 degrees. Draw a triangle there. That's the 45, 45, 90 that we already saw that has a height of 0.7. So we can put that in our table. 0.7 and then 70 feet. And then the next seat is another 15 degrees. So that's 150. So then draw a triangle there. And the height there, that's another 30, 60, 90, so the height is 0.5, and then so then they have to climb down 50 feet. So again, that's the same triangle that we saw earlier. And then lastly, the 165 degrees, that's 15, the 1575, and that has the height 0.26, and then, so 25.8. So you can, if you've noticed already, right, there are some patterns here, like they repeat. The same few triangles show up here, and remember the goal first is just to fill in this table. So that's what we're doing now, and then we're going to figure out if we can come up with a function for this table. So is there like a function, a y equals equation that will spit out all of these numbers? So let's just fill in these numbers first. So we filled out half of our table, a little more than half actually, and then there are some patterns that we can use to fill out the rest. So if you notice, this 15, 75, 90 triangle showed up a few times. It showed up 4 times so far. So here are the 4 times that it showed up, right? At the 15 degrees, at the 75 degrees, at the 105 degrees, and then at the 135 degrees. So that's it's the same triangle, just rotated, so it has all the same lengths. And so it shows up those 4 times, and then they actually repeat down in the pit below ground, so they show up 4 more times. So here they are, and then now we can just copy those heights into our table. So at the 195, it has 0.258, so 25.8. And then at the 255, it has a height of 0.965, so the actual height 96.5. And then at the 285, which was already filled in our table, and then at the 345, so 2.45, and then 25.881. Okay, so that was one of the types of triangles that showed up. The 30, 60, 90 showed up a few times. It showed up 4 times as well at the top. So here they are. So those are the 4 places that so far that we have on our table. So the initial 30-degree seat, and then the 60-degree seat, and then the 120-degree seat, and then the 150-degree seat. So those 4 triangles show up 4 more times down in the pit. So so here they are. So now we can copy those lengths into our table. So at 210, it's 0.5, so 50. At 240, it's 0.866, so 86.6. And at 300, 0.866, 86.6. And then at 330, 0.5 and 50. Okay, and then the last type of triangle that showed up was the 45, 45, 90, and that only showed up twice. So it showed up here and here, and that had a height of 0.7. So those are already filled on our table, and then it gets copied down below. And then those are the last 2 places that are missing our table. So at 225 degrees, it's also 0.7, and then 70.5, and then at 315, it's 0.70, so 70.7. All right, so basically we filled out our table. So the summary. So the height of any seat on the streamer model is directly related to the sine. So the height is the sine of the degree. So for example, at seat 210, the height is sine of 210, which is negative, and so that's going to give you a distance of 0.5 that you have to climb, right? And then there it is on the model. So that's it. I hope you enjoyed it. See you next time.